Hi guys, this is Nature and Matter 105 and our topic is the 4 types of solids that exist. And this is part 1, and all I'm doing is just previewing the 4 types of solids, and then I'm going to talk specifically about the covalent network type of solids. So I'll preview, or I'll overview one of those 4 types. And then in part 2, I'll go into Ionic Solids, and part 3 will be metallic solids, and then part 4 will be molecular solids. So anyway, there are 4 types of solids that exist in nature, and I'm just going to list them kind of across here. So we'll start with the covalent network. Solid. And then we have ionic solids. And then there are metallic solids and molecular solids. Okay, and as you go this direction, the substances become harder to melt and harder to boil because the attractive forces are stronger. So we would just make a little note of that. These are harder to melt and boil because attractive forces are stronger. And that's between the particles. So obviously the covalent network solid would be the hardest to melt or boil, and then we have down here the molecular solids. So just as a quick note, covalent network solids, there are 3 examples of these that I really want you to know. These are diamond, which is carbon only, and quartz, which is SiO2, and sorry, this is kind of going over into my definition, graphite, which is also made of carbon. Sorry, that's squished. So these are non-metals, and we'll go more into those specifics in just a minute. Ionic solids are made of a metal and a non-metal bonded together, or a polyatomic ion. So ammonium or any one of the polyatomic ions that you have come to love over the years. Metallic solids are made of all metal. And molecular solids are made of, again, non-metals. And these are molecules. So like NH3, H2O, C2, H6, any of those types of molecules as an example. Okay, so we're gonna get into this first one. So I'm just going to number these 1, 2, 3, 4. So number 1 is a covalent network solid. And these are an example of a 3-dimensional lattice where atoms are bonded together with covalent bonds. So that's one thing you want to remember. And then the other thing, sorry about the birds, the other thing you want to remember is that these are the hardest naturally occurring substances. Okay, so as an example, I'm just going to draw a little diagram over here. So we could have, let's say we have carbon like this, and these lines here are the bonds between the carbons. And then they make a three-dimensional lattice. So you could think of a cube kind of thing. And then it's just a repeating unit over and over again. So there'd be another carbon out here, carbons down. Okay, so it's just a repeating unit of carbons bonded together. And these lines represent covalent bonds. So a shared pair of electrons. And the three, as I said, the three examples that you need to know are diamond, which is a three-dimensional lattice of carbons where they're all bonded up and down. So that's carbon bonded on all 6 possible sides. And quartz, which would be silicon dioxide in a similar situation. You'd have silicon and then oxygens and silicon and then oxygens instead of just carbons. And then you have graphite, which is also carbon only, but instead of being bonded in 3 dimension, graphite is bonded in sheets of carbons, so they're bonded like horizontally but not vertically. So you can think of these as sheets of carbon bonded together, and this is a 3-dimensional bonding here. And this is also 3-dimensional bonding. So those are the 3 that you need to know for covalent network solids. And that is taking care of number 1. And just because I've got a little bit of space here, I'm gonna go into number 2, which are ionic solids, and then I'll continue this in part 2. So ionic solids are also a 3-dimensional lattice. Network. At the corners are ions, like a metal with a non-metal bonded to it, or a polyatomic ion. So what you might see is a sodium ion bonded to a chloride ion, and that sodium is bonded to another chloride, and that chloride is bonded to another sodium, and then it continues in 3 dimension out. So the corners are sodium, and then you have chloride here. And then they are bonded together in 3 dimension. So in a cube, and then this is just a repeating unit over and over again. So at the corners, again, are ions, and they can also be polyatomic. So in these corners, there could be molecules which are polyatomic ions. Okay, that's it for part 1. We'll continue with ionics in part 2. Thank you.